temperature data, probably anomalous data, from 1904, and it goes 19 units at five years at a time. So it goes from 1904 to 1999 in half a decade increments, okay? So now we've got 20 data points that go from 1904 to 1999. And what this line does here is it assigns a coefficient to each one of those numbers. And you can notice that in the early time points, the coefficients are very low and sometimes negative. What that does is it drives that number down below the zero line, right? Then as you get farther and farther out to the 1960s, 1980s, and 1990s to today, these coefficients go up and they get higher and they get higher, right? And he calls that, he's raising it up, he calls this the fudge factor, right? This is his comment, it's a fudge factor. It's incredible. This is not science. So, what they did, a guy named McKittrick, he figured all this out, and he found out that if you take this model, okay, that was used to generate graphs from Michael Mann's data, from his tree ring data, if you take all this code, this model, and you put what McKittrick calls, he calls it red noise, okay? Red statistical noise, it's just gibberish numbers. When you feed it into this program, it generates a hockey stick every time. Almost every time. It generates one 9 out of 10 times. And here's a sample of his runs. He made 6 or maybe 8 runs. And you get a hockey stick every time. And it's just background noise. So, you're bound in terms to get a hockey stick out of it. So, this is the way the world really exists, okay? This is the way the world really exists. We have graphs all over the world. Scientists independently have shown this. This is the medieval warm period. This is the little ice age. This is where we are today. This temperature here is no different than this. It's nothing unusual about this. So we have declared, Joanne Noble, our friend from Australia, is very funny. And she has declared the hockey stick is dead. And the son of hockey stick, because Michael Mann kept coming out with all these hockey sticks called hockey stick number 98, number 99, and Brooke got involved and he came up with his hockey stick because he possibly thrown the numbers a little bit. And so all these hockey sticks, I think we finally killed them. Okay? Now, what's important about this is because the IPCC relies conclusively on this hockey stick business. This is the only physical evidence they have to prove global warming. Okay? So when you kill their hockey stick, you've basically driven the stake through their heart. You have no physical evidence anymore. They can scream and shout and jump up and down and call you a denier, and they can do this and say the earth is getting warm, and they can use fallacies and whatever they want. But the only physical evidence they had was this contrived hockey stick, which we finally put an end to. So here's some temperatures over the last 7 years. You can see that, over the last 7 years, the temperature's going down. Now, responsible scientists wouldn't say, wow, we're in an ice age and we can jump up and down and call the president and say, look, we're going into global freezing or whatever. This is just another cycle, right? And, so it depends on where you're at. Now, here this graph is kind of a summary that I want to go through real quick. And it'll kind of tie together all this temperature business, and we'll move on to something a little bit different. And what you see here, this is basically a plot of temperature over time. And we're going back to about the 1800s, and we're going up to today. This box here is actual observational data. The rest of this is extrapolated, and you can see that we're coming out of the ice age, the little ice age, right? And we have basically a temperature increase of about the slope of this line here is about 0.7 degrees centigrade per year per 100 years. I'm sorry, and everybody agrees on that. This is the basic slope of the line. This is how much the Earth is warming. We don't know what's causing it. We're just coming out of the ice age. Okay. Now, interposed on that, we have these oscillations. It gets a little warmer, then it gets a little colder, it gets a little warmer, it gets a little colder, it gets a little warmer. This is 1976, we started getting warmer. This is when everybody went berserk, because it started getting warmer. And they started looking at the slope of this line saying, well, this isn't 0.7 degrees, this is more like 3 degrees, right? And they don't realize that it's just a wobble over the main axis here. So the IPCC comes out with all of their models, and this is what they project. They project that the temperature is going to escalate according to here. Well, I project it's just going to do this, right? I mean, until something else naturally happens, and something will also happen and bring it back down. We're going to go into another ice age at some point in time. We're probably coming towards the end of the inter-ice age warming. You have to keep everything into perspective. When you look at temperature changes, you have to look at the slope of the line, and it depends where you start. Where's your baseline? If you look at the slope here, you're going to say, wow, we're getting really warm. But if you look at it over time and are reasonable about it, you can see that this is the real slope. Okay? So when we do some conclusions about temperature data, we can see that today's temperature is not unusual. Okay? We're in a warming trend from the last ice age, and we're cruising along at about 0.7 degrees centigrade per century. Pretty much settled. There are nested cycles of warming and cooling within this trend. You see that? I'll explain how this happens a little bit. The rate of temperature changes are dependent on your baseline, right? We talked about that. You can be dramatic and say, well, the temperature started rising very quickly at about 3 degrees per centigrade in 1980 and call that a huge dramatic global warming and we're all going to die. Or we can say, well, right now we're on a downward slope. We've got a negative 0.4 degree temperature drop, therefore we're going to have an ice age. But we don't want to do that. You want to look at the big picture. You want to find out where we're looking at the baseline. Past temperatures were hotter than they are today, so it's not unusual. Temperature is not dependent on CO2. Okay? The converse may in fact be so. It may be that carbon dioxide is dependent on the temperature. Okay? The solar bubble effect. Now here, this is the IPCC guys, the guys who put out these climate models, these mathematical models that describe that how it is mechanically and chemically and mathematically, how it is that global greenhouse gases, how it will heat the Earth. And one of the predictions is that if in fact the Earth is being heated by greenhouse gases, then there must be an increase in temperature above the equator. You have to look at this. Let me orient here. This is the equator, and this is 30 degrees north and 30 degrees south. This is the area that we generally call the tropics. Okay, and global warming theory predicts that the temperature signal in the lower troposphere, and this is the height, this is the altitude of about 9 or 10 kilometers. This is about where your jet airplanes fly. So if you're flying in a jet over the equator, and you stick your temperature probe up there, that if global warming is caused by CO2, by greenhouse gases, then the temperature should be warm. Okay? Their own models predict this. This is what you find when you actually do the experiment. When you actually do the experiment, you use radiosonde data from weather balloons. You float these weather balloons up there, and they send back the temperature data, and this is what you get. You get not only do you see a warming, but you see a cooling. So you look at the two together. This is what is predicted by the IPCC climate models. This is called the greenhouse gas signature, and this is the way the world really exists. The models don't work. They don't predict the signature of greenhouse gas warming. So that means that the warming that's occurring isn't due to greenhouse gases, it's due to something else. Here's the same data, put on a little bit easier to understand slide. This is the models. The models predict that there's a warming over the equator, okay, over the tropics area. When you get an altitude of about 8 kilometers, it maxes out, it's warmer than it is on the surface. Here are the actual observational data, where the surface temperatures actually go, the temperatures at 8 kilometers in the equator area are actually colder than they are at the surface. Completely abrogates, completely contradicts the theory of global warming as being caused by greenhouse gases. This is a similar plot showing that the temperature changes over the tropics. This is 30 degrees north, 30 degrees south, the area that we call the tropics right here. We show that over the period from 1978 to 2008, there is no warming. Okay, there is warming over the Arctic or the Arctic. There's actually cooling over the Antarctic. Global warming theory, that is global warming which is caused by greenhouse gas emissions, predicts that this level will warm, this level will warm, and this level will warm. Okay? They've got 2 out of 3. Well, in science, 2 out of 3 is not good. Okay? So their models don't work.